Right, one last time we are going to look at our polynomial regression, this time seeing what we can do with the lasso. The code that I've got here doesn't seem to work perfectly well for very low values of lambda. I'm not quite sure why that is. Maybe it's something to do with sklearn, maybe it's something to do with my program, but I don't seem to have the problem elsewhere when we move into Amy's pricing. We're generating the data again. Now, the lasso regression, if you remember, our first model was linear_regression. The second model from sklearn was lasso, and this one is still from the linear model suite over here. We are importing lasso. There's also something called ElasticNet, which we're not going to use right now. Let's try a few different penalties. First of all, we're going to try a large lambda. Interesting, if you remember, in ridge regression, I'm fairly sure the value to make lambda large was something like 256. It was something big, whereas over here 1 seems to be sufficient. Well, it's lambda polynomial for degree 15. Where is everything? It's all disappeared because the coefficients of all the other variables besides the intercept were actually set exactly to 0. If you remember, ridge regression, on the other hand, going back a little while, had coefficients like e to the minus 8, 1 times e to the minus 8, whatever, but they weren't 0. Here they've literally been set to 0. Let's make the lambda a little bit smaller, see if we pick up something. Again, we've picked up 1.069x squared plus 0 times x. Again, x has been penalized right out of this model, plus some kind of intercept. Let's stick with this model and plot it. There you go, it's unsurprising, it's only a quadratic. Let's make lambda just a little bit smaller. I've got to note that 3 zeros before seems to do the trick. I didn't like that. We start getting some kind of error message. But you can see that it's fitted a fairly decent model. What I did want to do was make lambda really small to show you once again that when penalization disappears, we get back to our crazily complicated model. That isn't happening here, so I feel like there's some kind of problem with sklearn, or maybe there's something peculiar about the way I've generated this data. But either way, I think the main thing I wanted you to see here is how coefficients are actually being penalized to 0. Here's another one, for example, 0x to the 5, 0x to the 4, 0x cubed, something x squared, and so on. This is very useful if you want interpretable models where you're fitting models over data which has hundreds of coefficients, and you want to be able to hundreds of features, and you want to be able to explain the resulting model to your stakeholders.